Thank you very much. My name is Shigeo Yoden from the Graduate School of Science. And our contribution for the education basically for the part of the climate change issue. And we have English class for the master course and also the field training course using the field facilities of DPRI in Shionomisaki and Shirahama, southern part of the Honshu Island, and also the MU radar system in Shigaraki in collaboration with the Research Institute Sustainable Human Sphere. And today I mostly focus on the research aspect in a group and myself. And our research activity largely related to the WCRP SPARC program, particularly for the understanding climate variation and change in the Stratosphere-troposphere coupled system. So this is the homepage of WCRP, World Climate Research Program, and the history of several decades. And I think the WCRP aims to determine the predictability of climate and the effect of human activities on climate. And the SPARC is one of the 5 activities under WCRP. SPARC stands on the stratosphere-troposphere processes and their role in climate. And this community has a very strong point of the collaboration with the atmospheric or climate dynamics and atmospheric chemistry. For example, ozone hole issue is one of the biggest targets we have done in the past. And this is our recent report on our activities. And the title is Stratosphere and its role in the tropical teleconnections. And this is one of the hot subjects. And this figure is a satellite image provided by the Japan Meteorological Agency, GMSS satellite Himawari 8. And this is a true color image. And you can see the large aggregation of the convective systems. And we notice this is a typical Marden-Julian oscillation. It has a time scale of several weeks or a few months. And that covers this kind of size. But each component consists of this kind of convex systems. And the Marden-Julian oscillation is an aggregation of this kind of system. And our interest in the vertical coupling, this is basically the phenomena in the troposphere, but the condition in the stratosphere also influence this kind of activities. And this is a kind of a summary of the spatial and temporal scale of the atmospheric phenomena. And these days, multi-scale interactions of these phenomena from small scale to planetary scale, and very short time to annual or interannual time scale, very important. And as I said, the tropical process is largely different from that in mid-latitude. And important thing is the energy source is that small-scale convections in the tropics. On the other hand, in the mid-latitude, the large-scale component dominate. And in the last several decades, there is much improvement of the numerical modeling in the extratropics. So nowadays, we have a very accurate numerical weather forecast in middle latitudes. But in the tropics, it's totally different situation. And the large uncertainty of the climate projection exists in the tropics. still we have a poor performance relatively to the middle latitude. One of the interesting phenomena is the equatorial QBO, quasi-biennial oscillations of the zonal mean zonal wind in the stratosphere. This is the time height sections from 10 kilometers up to 30. So here is the lower stratosphere, and you can see the very regular interannual fluctuations. And if we have a linkage of this to the troposphere, this is a very predictable component. Okay. And these days, there are lots of work on the remote influence of the QBO to the tropical tropospheric variations. And here's some summary diagram of our recent research activities, international collaborations on the research on the stratospheric influence on multi-scale interactions of moist convection in the tropical troposphere. As I said, the moist convection is a key component, but it's modulated by a diurnal cycle, and also organization of moist convection produces a typical tropical phenomena, tropical cyclone, and also the Madden-Julian oscillations. These have a week to month time scales. And we also have a very clear annual component forced by the seasonal cycle. And we call it a monsoon. And longer time scale, El Nino southern oscillation is a very clear signal in the tropics. And longer time scale, we have a climate change issues. And the important thing is there is a linkage, holds a range. At the same time, if we look at the stratosphere, they also have intra-seasonal to interannual timescale variations. And the QBO is a very clear one, and the solar cycle over 11 years also another. And these days, there are very clear cooling trend due to the human activities. And these also have impact for the societal activities, including a short time scale, gusty wind, flash flood, and also the economic activity in the intra-seasonal time scales. Much longer time scale, drought, and the biodiversity, this kind of application we have to study. In the last several years, we organized international works to start the international collaboration, the stratosphere dynamic coupling in the tropics. Yeah, we started a small group, and last year we had a joint workshop of several activities under the SPARC. And so this is a group photo of the participant. And currently we are going to prepare the next large SPARC General Assembly this year in Kyoto in October. So we have over 550 abstracts and expecting 400 participants or so. Okay. So I think that these are our activities for the recent collaboration in the international communities. Okay. Thank you very much for the participation.